Hi, my name is Adnan Iftikhar, and this is my MSc project presentation. And my title of the project is Adaptive Safety Moderation for Large Language Models. So, first of all, uh, coming towards the first slide, that is abstract and problem statement. So, the problem LLM safety is a system problem. A single detector often misses harmful content and sometimes over refuses safe request. I evaluated a pipeline with routing specialized experts, collaborated aggregation, and a policy for actions. Our baseline, our baseline is a collaborated linear SVC. Accuracy is 0.795, macro is F1 0.795, and AP unsafe is 0.863. So it misses 587 unsafe prompts, that is 22.3% of the jailbreak, and flags 472 begin prompts, that is 18.5% over refusals. So now, if we talk about our approach, we evaluated a modular moderation pipeline consisting of routing specialized experts, collaborated aggregation, and on explicit policy allow, clarify, redact, or block. Like if someone is giving a prompt to the AI and they are trying to self-harm them, so it will just simply be blocked and the response will not be given by the AI. So the proposed improvements, category aware routing, the first thing, and then severity aware override to clarify redirect in the mid band, and auditable rewrite tags for PII. Okay, now moving towards the next slide. Yeah, that is introduction. So LLMs are in many products. Safety failures, harmful text, overblocking, and low transparency have real impacts. So currently thinking, use layers like a red teaming, guardrails, and governance. My work focuses on a layered moderation system you can tune and audit. Now, if I talk about a research question a little, so the research question is, can a modular safety layer with routing experts, collaborated aggression, and policy reduces harmful misses without bad latency or over blocking? So the objectives: design the pipeline, set tunable policy thresholds, and evaluate robust and coast against the strong baselines. So now moving towards the next slide, that is related works. So So in summary, prior to the related works that have done, I have figured out a few things that guard models, these are good coverage, but sensitive to data sets and languages. The second one is decoding time methods. So in this one, model agnostic, but can add latency. So the one more was collaboration, or you can call abstention. So better threshold, but need validation data. Benchmarks, the most popular one, useful for comparisons, but have coverage gaps. But have coverage gaps. So if we talk about the risk type detectors, so precise for domains, but suffer domain shifts. Like you trained on one domain and the domain shift, so it really struggles. So this guided my choice to composes multiple paths instead of relying on one guard model. So I basically developed my local model, and I retune an already existed model as well. um, so if we talk about the research methodology, the next slide. So if we talk about approach, my approach is a controlled comparison, baseline detector versus adaptive system. Datasets, curated safety, corpa for training, held out test set public red trimming suits jailbreak ML commons v0.5. And if we talk about the system components, so baseline TF IDF plus linear SVC trained via stratified splits and plot scaling collaboration. I will show you these when in the second part where I'll be showing my code, that how was the research methodology, how was the system components, and how I coded all of them. So if we talk about the evaluation metrics, accuracy macro F1 precision recall, collaboration policy outcomes jailbreak or over refusal statistical analysis. So MC and Nemer test on error disagreements, bootstrap CLS for macro F1 and AP, elevations, no routing, single expert, no collaboration thresholds. Simple. So now moving towards the sixth slide, that is system architecture and design. So here's my architecture. Pre-processing and context routing to likely risk categories, specialized experts, return unsafe probabilities, then moving towards the aggregation and calibration produces one risk score, and then the policy and rewrite maps. So, like uh, allow, clarify, redact, or block any responses. So we can also log and audit trail category scores, final action, and then redact spans for governance. So now moving towards the implementation and pipeline. So first talk about the deliveries. Deliverables. So the collaborated linear SVC baseline and the adaptive system. Uh, and the technologies that I use is Python version 3.10 plus. Libraries are skitlearn and SVM calibration transformation, and also I integrated Streamlit with this. So like it gives you an UI where you can test your prompts after retuning or training your models that are in my case. So now moving towards the evaluation hardness. So the performance metrics accuracy 0.79, macro F1 is 0.795, AP is 0.863, confusion metrics is true and negatives are uh, 2074, false positives are 472, false negatives are 487, and true positives are 2042. So the jailbreaks are 22.3 and over refusals are 18.5. Here you also can see these graphs. Yeah. So now moving towards the system policy. So if we system improvements. So in system improvements, you can see baseline jailbreaks are 22.3, 18.5% over refusals, and the system is 14% jailbreaks and 15% over refusals. Threshold effects, lowering catches, borderline harms, example, hateful phrases of cost of like more refusals, collaborated score makes more trade-off predictable, and severity override, mid-bond default to clarify or redirect, or hate, self-harm reduce, swear misses search as overheat sentiments. Like I have or added these prompts, and but I will show you these once I'll be in the second video where I'll be presenting my code. So, conclusion and the future work. So, a modular collaborated moderation layer with routing experts, aggregation, and policy outperforms a single detector. It provides tunable trade-offs and full logging for governance. So, if I talk about the limitations, then the limitations are it's an English centric data, so no other language can be beneficial. With this one, expert bias, and it may affect with the domain shift and limited multilingual. And my future work, so I just want to enhance this one, not in a single language, as it's a limitation now that it's unfortunately it's only English centric, because I was not finding other data sources on this one. So uh, like the future work, so this project idea was like 2 years back I heard a news that a kid asked some AI that he's depressed and he want to commit a suicide. So the AI gave so after this prompt the AI gave him the most best ways to commit a suicide. So that is the only reason I just want to make the use of AI very safe. Like if something is harmful, hate speech, or that can spread fire, so it gets blocked and the AI just simply don't respond to that. So I'm ending this video, and in the second video, I'll be walking you through from my code and my implementations. Thank you so much.